Right, now let's look at question 16. So here, Ali is arranging the books on his bookshelf. He put half of his books on the bottom shelf and 2/3 of what remains on the second shelf. So finally, he splits the rest of his book over the other two shelves, which means the first and third shelf, so that the third shelf contains 4 more books than the top shelf, and there are 3 books on the top shelf. How many books are there on the bottom shelf? Okay, so for this question, of course, you can just draw 4 kind of shelf to better kind of organize the conditions. So at the top shelf, we have an actual number that is 3. And then on the third shelf, it's 4 more than that. So that's obviously 3 plus 4, which is 7. Okay, then for the other 2 shelves, we only know the kind of fraction of the books to the total. So for the bottom one is half of the books. And then for the second layer is 2/3 of what remains. So what remains is definitely like 1 minus a half, which is a half, and then 2/3 of it, you are basically doing 2/3 times a half, and that will give you 1/3. That means the second layer contain like 1/3 of the books. Now we want to find the bottom shelf one. So in this case, you actually need to relate these fractions with the actual numbers that you have. So our strategy is to find out what's the kind of fraction of these 2 layers and relate it to the actual number we have. So we know in total with fraction for all the books, that would be 1. And then on the second layer, 1/3, on the bottom layer, a half. So if you use 1 to subtract these 2 fractions, you will get 1/6. That means for these 2 kind of layers, their books add up to 1/6 of the total. And for these numbers, if you add 3 and 7, that's actually 10. That means 10 is 1/6 of the total. If 10 is 1/6 of the total, you can just do the kind of actual value divided by the proportion or the fraction it's taken part in, the whole. And that will give you 10 divided by 1/6. And that will be 10 times 6, and that will be 60 in total. Okay, since it's 60 in total, you want the bottom shelf is a half, you just do 60 times a half, that will give you 30. So D is the answer here. Right, so that's this question. Now let's look at question 17. So here, a large circular table has 60 chairs around it. What is the largest number of people who can sit around the table so that each person is only sitting next to exactly one other person? Okay. So for this question, you can first try to picture it. We have like a circular table, we have lots of chairs around it. So let's try to kind of zoom in and look at part of the kind of table. So let's say if I have a person here, then can I sit another person next to it? Yes. So if it's exactly 1, that's doable. But can I sit another person next to this one? No, because in this case, the middle one will be sitting next to 2 people. So that means for the next one, you will have to leave a space. And now, because we want the largest number of people, so you want to fit in as many people as possible. So for the next one, you don't want to leave another blank. You want to fit in another person. So if you put in another person, and again, we can just continue and put another person next to the person and then leave a blank, and then we can just go on like this. Okay, so everyone, do you notice any pattern? Yes, the pattern is that if you want to fit in the largest number of people, this is the pattern that can work, that would give you 2 people and a space, 2 people and a space, 2 people and a space. So they are in a group of 3. So if they're in a group of 3 and there are 60 chairs in total, you can just do 60 divided by 3, and that will give you the total number of groups. That's 20. So that means there are 20 groups. But is that the final answer? Not really, because in each group, there are 2 people. So you can just multiply that by 2, and that will give you 40 as the kind of maximum number of people that we can fit in. As here, when you divide it, there's no remainder. So there's no kind of special situation you need to consider, because when you do a circle, finally, for the last kind of group, you're going to have people, people, and then space. So that perfectly connect. So that's this question. Nice. Now let's look at question number 18. It's a very nice one. Here, the points P, Q, R, S are marked on a straight line in some order. So the length of the line segment P, Q, Q, R, S, S, P are 13, 11, 14, 12 centimeters respectively. What is the distance between the 2 points that are furthest apart? Right, for this question, first of all, don't get yourself confused. I know some of you might be drawing and think, how is that possible? Right, so they are not in the order listed. They are in some order. That means they're put randomly. Okay, and if you want to find what's the distance between the 2 points at the furthest apart, then of course you want to see where are those PQRS, what is the relationship. Okay, so let's make a start. So I want to make a start by drawing some lines, and now we're going to put the PQRS on them. Okay, so let's try the first one. So here, the position of them is unsure, but the length of them is sure. Let's just pick one of them. Let's pick the first one. It doesn't matter which one you pick. So if you start with PQ, this is PQ, and we know it's 30 centimeter. And then when you say QR is equal to 11, everyone think about it. Where could the R be? Right, the R could be on the right side, and this would give you 11 for this bit. However, it could also be on the left side. So it could also be here. And then when we move to RS, S could also be on the right or on the left. So it's becoming a little bit kind of too complicated. So now from the second one, I would like to split them into two kind of lines so that everything is more obvious for you. So let's say again, PQ is 13 centimeter, but this time my R is on the left side of Q, and this would give me 11 centimeter. So let's call it R2. Right, now let's move on to RS. So with RS, as we said, the S can be on the right, can be on the left. RS is 14 centimeter, so it can be 14 centimeter away from R on the right. And let's put it down as 14. It could also be on the left. So it could also have this bit as RS. It's also 14 centimeter. Okay, now the thing is, we also have the last one where SP is 12 centimeter. Well, SP, they're all the points that's already on the diagram. So that means you need to double check whether you can have SP as 12 centimeter. So over here, for the S1, of course, it's impossible. It's too big. It's way larger than 12. With S2, let's look at it. So since SR is 14 centimeter, this is 11, so that means SQ is 3 centimeter. And if SQ is 3 centimeter, then in total PQ is 13. That means SP is 10 centimeter. But we want it to be 12. So it actually doesn't work in this case. Okay, so in this case, where R is on the right side of Q, neither of the case would work. Right now, let's look at this case. If R is on the left side of Q, and again, if we move on to RS, your S could be on the right side of R or left side of R. So RS is 14, so let's look. So R is here. If it's on the right, this is going to be your RS, and it's 14 centimeter, and this is going to be S1. It could also be on the left, and this will be your 14 centimeter. And in this case, this is S2. Now let's use SP to examine it. So with SP over here, obviously is greater than 12 centimeters, so it doesn't work. While with S2P, very close. So here we know this PQ is 13, RQ is 11, that means PR is 2. If PR is 2, SR is 14, that means SP is 14, take away 2, that is 12. And that perfectly satisfies our condition where SP is 12 centimeter. Okay, so that means this S2 and this R2 is a position that works. Now let's look at the distance between the 2 points that are the furthest apart. Again, the S1 doesn't work. So over here, the workable points are just from S2, P, R2 to Q. That means for the distance that you're looking, you just need to see how long is it from S2 to Q. So we know this is 12. Let's put on 12 and then 2. And then here's 11. So just add them up. And that will give you like 23 and then 25. So B is the answer for this question. So don't be scared by how complicated it is. Just kind of find a clue. Know that it can be both on the right or left. And then just kind of list them and find them out step by step. Right. Now let's look at question 19. So here, my television has sides in the ratio of 16:9. My mother's television has side length in the ratio of 4:3. A picture which exactly fills in the screen of my TV only fit the width of the screen of my mother's TV. So what fraction of the screen on my mother's TV is not covered? Okay, so over here, you can see that if the width kind of fills exactly, That means they should be of the equal kind of parts. However, now we have the length as 16 parts, and this is 9 parts, and this is like 4 parts, 3 parts. So it doesn't match. So what we can do is to kind of scale it so that it matches up. Right, fills the width. All right, sorry, everyone. I think we're talking about in a slightly different case where the bottom one is the width, the side is the length, but it doesn't matter. So you only need to know the longest side would fit in. Okay, so if you want to make the full 16, you can kind of scale up your ratio and multiply it by 4. You're going to have 16 to 12. Okay, so that means this side is 16 parts and this total is 12 parts. That's perfect. This is 16 parts as well. If you make this equal, you can fit in the kind of 9 part over here. You will see that this is 9. So if this is like fit perfectly, if you want to find out the fraction that's not covered, you can just do the length that's not covered to the total. And that would be 12 minus 9, which is 3, and over the total. And that will give you 3 over 12, and that is a quarter. Okay, so for this question, it's a quarter of them that's not covered. Right, now let's look at question number 20. So here, Stephen subtracts the units digit from the tens digit for each 2-digit number. He then finds the sum of all his answers. What is the value of Stephen's sum? So over here, what we're doing is we're looking at the 2-digit number. So 2-digit numbers are the numbers from 10 to 99. And we are subtracting the unit digit from the tens digit. So for this question, there are 2 approaches. Let's do the standard one first. For the standard one, let's first look at the example. Let's say if I have 32, then subtracting the unit digit from the tens digit means that you're going to do 3 minus 2. If I have 96, then to subtract, I'm doing 9 minus 6. So we're using all of those tens digit to subtract all of those units digit. So if you want to find the sum, the result, you can just find the sum of the tens digit and let it subtract the sum of the units digit. Okay, so with this one, for the tens digit, then let's look at it closely. Let's try. So if you have 10 to 99, you can group them into, let's say, 10 to 19, and then 20 to 29, 30 to 39, and all the way to 90 to 99. Okay, so for each group of them, if we look at the tens digit, so for the first group, I would have 1 as the tens digit. How many 1s are there? There are 10, as there are 10 numbers here. And this group, all of the tens digit, there are 2. How many 2s are there? There are 10 as well. So for each group, there are 10 numbers. And for the tens digit, it's always like 1 and 2 and 3 and 4 all the way to 9. So you just need to add from 1 all the way to 9. And there are 10 lots of them, so do 10 times. So that's the sum of tens digit. And then for the sum of the units digit, so now if we look at them in this way, so for the units digit, you see for each group, you have the unit digit from 0 to 9, right? You have like 0 to 1 to 2, all the way to 9. And that's for each group. How many groups are there? There are 1, 2, 3, all the way to 9 groups. So that means for the sum of the unit digit, you would also add up 1 to 9, but this time there are 9, lots of them. So you can just do the subtraction. But of course, everyone, you don't need to kind of find the actual value out yet. You just need to see that, okay, so here 10 lots of them, here 9 lots of them, the 0 doesn't make a difference. So that means with this kind of difference, that would just be 1 lots of set of them. Okay, so if you want to add from 1 to 9, you can do 1 plus 9 times number of terms divided by 2, and that's going to give you 45. Okay, so that's the answer, actually, B. Right, now let's look at the second approach for question number 20. So here, let's use the page problem to help us understand better. So what we are looking for is a sum of his answers, where the answers are getting from subtracting the units digit from the tens digit for 2-digit numbers. So if we don't think about digit number, let's talk about all numbers that's under 100. So from 9 to 99. So if you put out a table, you will notice that for every single digit other than 0, they would appear in a table 20 times. Okay, so for example, for the 6, you can see that 6 appears 10 times in the units digit, and 6 appears 10 times in the tens digit as well. So that means there is the same number of 1, 2, 3, 4, 5, 6, 7, 8, 9 in the units and the tens digit. So that means when you subtract the sum of the tens, sorry, if you subtract the sum of the units from the sum of the tens, you're gonna get 0 if it's 1 to 99, okay? But we're talking about 2-digit numbers. So we are talking about from 10 to 99. That means for the units digit, when in the first row from 1 to 9, that's not counted in. That means we have less. The sum of the units digit is less than the sum of the tens digit. And that difference is just the sum of the first 9 single digit. Okay, so in this question, you can just kind of ignore like what we do with the first method. You just think, okay, that difference is made by the kind of 9 single digit that's not been counted in. So for the difference of them, it's just going to be 1 plus 3, 2 plus 3 all the way till 9. And that is 45. Okay, but honestly, it's a little bit abstract to think about this. You really got to understand the page problem quite well. So I'm just kind of putting it here. So if you can understand, that's fine. But if you cannot, that's absolutely fine. Take the traditional approach. Okay, so that is this question. Hope it makes sense for everyone.